welcome back. So now in the last lecture we have seen voltage division rule and current division rule, and now we will solve simple problems on these voltage division rule and current division rule. First of all, let's take a simple question on this current division rule, right? See, find the currents I1 and I2 in the parallel circuit shown in the figure 3. So this is a simple circuit. If you can carefully see, there is a current source 20 amperes, and this current I, which is equal to 20 amperes, it is flowing into this path and also into this path, I1 and this I2. And these two paths are, this is path 1 having 5 ohms resistor, and this is path 2 having 10 ohms resistor. And if you carefully see, both are in parallel. Am I clear? So see, this is the circuit. So when both are connected in parallel circuits, we have seen that which rule is applicable? Current division rule is applicable. Then what does it states? Current division rule. The ratio of currents is proportional to inverse of resistance values. So I1 is to I2 is equal to inverse value of resistance. What is it? 1 by 5 is to 1 by 10. Isn't it? So what is 1 by 5 is to 1 by 10? So I can simplify for you here. 1 by 5 is to 1 by 10. What is LCM for them? It is 50, right? Or I can, so it is 10 LCM, right? LCM is 10. So 5 2s are 10. This is 5, 10 1s are 10. So if I take them off, 2 is to 1. So I can directly write it as 2 is to 1. So I1 is to I2 is 2 is to 1. Isn't it? So in that case, actually what is the total current? Total current is 20 amperes. And in that one, I1 share is 2 parts, I2 share is 1 part. So how to determine I1 then? Its share is 2, but total number of shares is 2 plus 1 into what is actual current? 20. Similarly for I2, its share is 1, total shares is 2 plus 1 into total. This is the concept. Understood? Now we'll move on to one more problem. See, find the voltage across resistors. This is, if you see, it is a series circuit, right? So in this case, how to determine the voltage across these resistors? So which rule will be applicable here? Right? Voltage division rule will be applicable because these are series connected circuits. So in that case, what is voltage division rule? The voltage, the ratio of voltage drops across the elements is proportional to the ratio of resistance values, isn't it? So V1 is to V2 is equal to R1 is to R2. What is R1 is to R2? It is 6 is to 10, right? So I can write 2 3s or 2 5s. So it is 3 is to 5. Or I can keep it as 6 is to 5 also, no problem. So what is V1 share? What is the total voltage? 12 volts, right? So its share is 3 out of how many shares are there? 8. 3 plus 5 is 8, right? If you want, I will write it as 3 plus 5. Into what is the actual value? 12. So 12 3s are 36 by 5 plus 3 is 8. 8 1s are 8 4s, 4.5. 4.5 volts. Similarly, V2. Its share is 5 by total number of shares is 8 into 12. 12 5s are 60, 60 by 8, 8 7s are 56, 7.5 volts. Right. So this is the way how we determine. So, what is the conclusion which we have drawn? A parallel circuit acts as a current divider circuit because it divides the total circuit current in all its branches. Whereas a series circuit acts as a voltage divider circuit. And the current division rule states that current in any of the parallel branches is equal to the ratio of opposite branch resistance. You don't try to remember too much amount of these things. Current division rule states that I1 is to I2 is to I3 up to IN is equal to 1 by R1 is to 1 by R2 is to 1 by R2. Like that. Similarly for voltage division rule, I think this will be easier for you to remember, right? This will help you a lot. But try to remember, this is applicable only for parallel connected branches. This is applicable only for series connected branches, right? So I hope that now you are able to determine the branch currents and voltage using voltage divider rule and current divider rule, right? So with this, I'll close the session. Now you are supposed to do problems on this one. See, a sample problem has been given for you. There are three resistors having resistance connected like this. How to determine the voltage across these three things? I'll give a hint for you. See, these are connected in series. So which one is applicable? Voltage division rule is applicable. So V1 is to V2 is to V3 is equal to 100 is to 200 is to 300. Right. So I can simplify it. 1 is to 2 is to 3. So what is V1 share? Its share is 1. Total number of shares is 1 plus 2 plus 3. Into what is actual voltage? 250. Similarly for V2 it is, its share value is 2. Similarly V3. Understood? So try to solve these problems and we'll solve more at our home. So this is one more lecture level problem which you are supposed to practice at home. Here also, I think I told you, these are all parallel connected resistors, right? You can easily identify them. So in that case, what is I1 is to I2 is to I3? 1 by 10 is to 1 by 25 is to 1 by 100. So these are a little bit complex things, right? So don't get confused if you are having this type of fraction things. Yes, you do LCM for them and ignore the denominator parts. See what I will do. What is LCM for these things? 10, 25, 100. 100 is the LCM, right? So 10 tens are 100 is to 25 is 4 times it is 1. And just eliminate the denominator part. So the ratio is now 10 is to 4 is to 1. So what is I1 share? 10 by total 15 into whatever the current which you are getting here, that you should determine. Okay. So with this, I'll close this session and tomorrow we will discuss about source transformation. Okay. So thank you once again. We'll meet in the class to discuss more number of problems.